So let's suppose this is point A, this is point B, and this coordinate of this point x1 comma y1, this point is x2 comma y2. Okay.
Yes.
So slope of line AB will be equal to y2 minus y1 over x2 minus x1. Okay. So this is simply the slope of line AB. Okay. Now let me draw a random function any. Let's suppose this is any function. Okay. This is a graph of the function y equal to fx, and this is x-axis. Okay. And I am taking 2 points. Okay. Okay, before coming to this direct with this definition, let me tell you what is the meaning of average rate of change and instantaneous rate of change. Okay, so after that we will come to this definition, because the same thing I will analogous here, so I will explain here. Okay, so first let me tell you, let's suppose you are going from your home to school. Okay, you are going from your home to school, not in a straight line, in any path. Okay, this is your home, this is your school, and let's suppose distance is somehow 35 kilometers. Let's suppose. Yes. And let's suppose you are just taking, let's suppose 36 kilometers, and you are just taking let's suppose 2 hours of time. 2 hours of time. Okay, that means the total distance that you have covered is 36 kilometers upon the total time that you have taken 2 hours. Okay, that means your average speed will be 18 kilometers per hour. Okay, just for example, your average speed will be 18 kilometers per hour. Okay, and let's suppose this is a particular point between your home to school. At that point, let's suppose this is point C. At this point C, you just passed with a speed of, at point C, you just passed at a speed of, okay, at a speed of, let's suppose 21 kilometers per hour. Okay, and it is obvious that throughout the way from home to school, you will not move with a constant velocity or constant speed. Obviously, there some at some point it will be higher than some speed, and sometimes it will be lower than the average speed. Okay.
Yes.
Okay, that means this 21 kilometers per hour at point C is your instantaneous speed. Okay, and this 18 kilometers per hour is your average speed. Okay. That means average rate of change of distance between home to school is 18 kilometers per hour, and at point C, the instantaneous rate of change of the distance with respect to time is 21 kilometers per hour. Yes. I hope you got the difference between average and instantaneous here.
Yes.
Okay. Now similar is the case of function. Let's suppose this is point A and this is point B. Let's suppose its coordinate is x comma f of x, and its coordinate is, let's suppose this is delta x, let's suppose. Okay, this is delta x, so this is x comma f of x. This will be x plus delta x comma f of x plus delta x. Okay.
Yes, sir.
Now I will write the slope of line AB. So slope of AB. Basically, when a line cut any graph into different points, that line will called secant. Okay, so basically the slope of AB means this is the slope of this secant. Okay, and it will be y2 minus y1. what is y2 at point B? I mean to say, what is y at point B? It is f of x plus delta x. X plus delta x minus y1. That means the y coordinate at point A. That is f of x upon x plus delta x. That is x2 minus x1. That is x. So this is basically the average rate of change of y with respect to x. Okay, because I have just taken the final values, the total change in the length of y upon the total change in the length of x. Okay, so this is called slope of AB, or this is also called average rate of change. Average rate of change. Okay, so basically this is the slope of secant. Okay.
Yes.
Okay. Now, in this example, I am taking a special case when delta x becoming very, very small. Delta x
Yeah.
tending to 0 means delta x is becoming very, very small. That means, just imagine if this delta x will be very, very small. So this is delta x. If this delta x will be very, very small, then what will you see? This point B will be on the point A or will be very near to the point A? If this delta x is very small, that means this point B will be very near to point A. Okay,
Yes, sir.
because delta x tends to 0 means delta x is very, very small, but delta x tends to 0, that does not mean delta x equal to 0. Okay, something approaching 0 means the value is very near to that but not equal to that. Okay,
Yes, sir.
okay, so delta x approaching 0 simply means the point B approaching towards point A. That means this secant AB will be converted to the tangent at AB, tangent at A. Okay, so
Yes,
this will
sir.
be tangent now. I hope you are getting the geometrical interpretation also. You are
Yes,
able to
sir.
imagine.
Yes, sir.
Since delta x will becoming very small, that means this point B will shift to the point A. Okay,
Yes,
that
sir.
means in this expression for the slope of secant, I will just put the limit delta x tends to 0. Therefore, the slope of AB, that is the slope of secant, will be converted to the slope of tangent. At which point? At point A. Okay,
Yes, sir.
that means slope of tangent at point A, slope of tangent at point A will be simply, I will just put limit delta x approaching 0, f of x plus delta x minus f of x over x plus delta x minus x. So can you see anything is cancelling here in denominator? So that means limit delta x approaching towards 0, f of x plus delta x minus f of x over x, sorry, over delta x,
Yes.
because x and x will be cancelled. Okay,
Yes.
so this is the slope of tangent at point A. This is simply called the derivative of y equal to fx at point A. Okay, so this is a standard definition of derivative at point A. Okay,
Yes, sir.
so basically the derivative of a function at particular point A is simply means the slope of the tangent at that point. Okay,
Yes.
okay, now let's take one example. This time I am taking f of x equal to x square. Have you studied the limits in your curriculum?
Yes, sir.
Okay, okay, so let's suppose I am taking f of x equal to x square. Okay, so we just want to find the derivative of this function fx. So we just need to find derivative of this function. This is our notation of derivative of f of x with respect to x. Okay, so derivative of function fx with respect to x, let's suppose at x equal to 3, we just want to find this. Okay, okay, so I will write the definition of derivative, that means differential of f of x over differential of x. This is the definition of derivative, so I will use this definition, okay, to find the answer for this question.
Yes.
So that means it will be limit delta x approaching towards 0 f of x plus delta x minus f of x over x plus delta x minus, although I have already simplified it, so I will directly write in the denominator delta x, not x plus delta x minus x, then x and x will be cancelled. That will be left with delta x. Okay. Okay. So that means limit delta x approaching towards 0. What is x plus delta x? I will just put in the function. What is function of x plus delta x? So it will be simply x plus delta x whole square minus f of x, which is x square, over delta x. Okay.
Yes, sir.
Now I will just expand. Now I will just expand the part in the numerator and simplify that, and then we will put just the limit. Okay, so it will be limit delta x approaching towards 0. It will be x square plus delta x square plus 2x times delta x minus x square over delta x. Okay.
Yes, sir.
I have just expanded this x plus delta x whole square. That means a plus b square. A square plus b square 2ab. Okay.
Yes, sir.
So differential of fx with respect to x will be limit delta x approaching towards 0. So x square and x square will be cancelled. We will left with delta x square plus 2 times x into delta x. So we will take just delta x as a common. So we will left with delta x plus 2x over delta x. Delta x will be cancelled here also. So we will left with limit delta x approaching towards 0, delta x plus 2x. Since delta x approaching towards 0, then this expression will be simplified to 2x. Okay, because this will be approaching towards 0. So differential of f of x over differential of x will be simply 2x. So this is the definition. This is the derivative of f of x. Okay.
Yes, sir.
Okay. So this is the definition of derivative of fx with respect to x. I hope you got all this, because this is, I have derived the derivative of f of x using the fundamental definition of calculus. Okay.
Yes, sir. Yes, sir.
Okay. So let me know if you have any doubt till now.
No, sir, I understood.
Am I moving fast, or is it okay for
No,
you?
no, it's fine.
Okay. So I have derived the formula for derivative of x square by using the fundamental definition of calculus. This is basically called the fundamental definition of calculus. Okay. Okay. Because
Yes.
whenever you will read the history of the derivative and the rate of change, so you will see that this is the definition actually the mathematician have used. Okay. So this is f of x plus delta x minus f of x over delta x. Okay, so this is called first fundamental definition of calculus, or the ab initio method. This is also called ab initio method. Okay.
Yes, sir.
Okay. Okay, so my question is simply was you need to calculate the derivative at x equal to 3. So what will be the derivative at x equal to 3? Derivative x equal to 3, it will be simply what? You just
2 into 3, it will become 6.
yeah, 2 into 3, it will become 6. Okay. So I have just explained to you how we can find the derivative using the fundamental definition. But every time we will not use the fundamental definition. We have some standard formula. Okay, so we will apply that formula to find the derivative of functions. Okay, so let me tell you those formulas. Okay. Okay. So derivative of x raised to the power n with respect to x, it will be simply n x raised to the power n minus 1. Okay. And let me just tell you the derivative of e raised to the power x with respect to x, it will be simply e raised to the power x. Okay, and the derivative of a raised to the power x with respect to x, it will be a raised to the power x into ln a.
Yes, sir.
Okay.
I'm writing this down, sir.
Okay.
Write these down.
Okay, so
Can you scroll a bit down, sir?
okay. More down.
Sir, down, sir. You're scrolling up, sir.
Oh, okay. Sorry.
Yes, sir.
Okay. So you have covered the trigonometric functions also, so that I can write the derivative of trigonometric functions too.
Yes, sir.
If you have covered the trigonometric functions also, so derivative of sin x, can you tell me? It is simply cos x. What is the derivative of 10x? Derivative of 10x will be simply sec square of x. What is the derivative of sec x? It will be simply sec x into 10x.
Yes, sir.
Okay, now the derivative of co-trigonometric functions. Co-trigonometric function means derivative of cot x, cos x, and cosec x. So derivative of co-trigonometric functions will be negative. That means derivative of cosine of x with respect to x, it will be minus sin x. Okay.
Yes, sir.
And
Yes, sir.
derivative of cot x with respect to x minus cosec square x. Okay, and derivative of cosec x with respect to x will be minus cosec x into cot x. Okay.
Yes, yes.
Okay, so these are the some derivative of standard functions. Okay, I think you have not covered the inverse trigonometric functions. If you
No,
have
sir.
covered, then I will write the derivative of inverse trigonometric functions also. Have you covered?
No, sir.
Okay. Okay, so okay, let me think if I can tell you some more trigonometric and exponential, polynomial. Yes, I think this is right. Okay. Now I am giving you function and you need to tell me the derivative using the so first I will take example on this first formula. Derivative of x raised to the power n equal to n x raised to the power n minus 1. Okay, so let me just take one example on this formula. So you just need to find the derivative of, let's suppose, x raised to the power 3 over 2. Okay, so what will
Yes.
be the derivative of x raised to 3 over 2? So we know that derivative of x raised to the power n with respect to x, it is simply n x raised to the power n minus 1. So can you use this formula? And can you tell me the derivative of f of x here with respect to x? That means, can you tell me derivative of x raised to the power 3 over 2 with respect to x? Can you simply use that formula? I am giving
Yes.
you 1 minute, or you can take also 2 minutes. So just tell me this answer. You just need to
Okay.
apply this formula. Okay.
Yes.
Okay.
So here we have n value is 3/2 then.
Yes, you got it. We have n value is 3/2. So just put 3/2 value of n in this formula. You will get the derivative of f of x. Okay.
Yes. So 3/2 into n to the power of 3/2 minus 1, that is half.
Yes. 3/2 times x raised to the power half. Okay. 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 Now, I will come back to this formula, but before that, let me just tell you what is the equation of a line whose slope and the point is known. Okay. Let's suppose this is a line whose slope is m and it is passing through any point. Let's suppose a whose coordinate is x1 comma y1. Okay. So do you know what is the equation of this line? Okay, let me tell you if you are not familiar. So y minus y1 will be equal to
m into x minus x1.
Okay, that means you have covered the chapter of straight line and circle also in your 11th.
Yes, sir.
Okay, so that means this is the equation of a line whose slope is m and passing through point x1 comma y1. Okay, I have just told you this formula because I want to ask you a question. Let's suppose you have a curve f of x equal to x square. Let's suppose x square. Okay, so find equation of tangent line. Okay, tangent line at x equal to, let's suppose 3. Okay, so this is the question. Okay, so equation of tangent line at x equal to 3. That means when x equal to 3, then what will be y? Okay, let me just draw this for you. I think you have already covered the quadratic equation also, but if you have not covered, so no problem. I am just drawing the curve of this function. Okay, so this is the y equal to x square. Let's suppose this is x equal to 3. Okay, let's suppose this is point A, this is x equal to 3. Can you tell me if x equal to 3 and what will be y? If x will be 3, then what will be y? Can you tell me that? Just put value of x equal to 3 here. So you will get f of 3. So f of 3 will be simply